Find the absolute maximum and absolute minimum values of f of x equals 3x squared minus 12x plus 5 on the interval from 0 to 3. Now it says interval right here, so these are our x values. So this is how the domain is being mentioned. So we need to check a few different things. We're going to need to check our endpoints, and we're going to need to check any critical numbers. So the first thing we need to do is figure out what we're working with. So let's see if we can find our critical numbers. Let's take our derivative, let's set it equal to 0, and we're going to make ourselves a list of points that we need to check. So first things first, let's see if we can get our derivative. So we're given f of x equals 3x squared minus 12x plus 5. So that means that our derivative would be, bring down your power, so 3 times 2 is 6, subtract 1, so x to the first, minus 12. Derivative of 12x is just 12. So derivative of 5 is 0, so that looks like it's done. So let's set our derivative equal to 0. Let's solve it down. Add 12 to both sides. Divide both sides by 6. So it looks like we get x equals 2. So we only have one critical number here, but we don't have only one number to check. So I'm going to make a list. I'm going to make my x's, I'm going to make my y's. So I have a handy dandy little list here to check. First thing on my list is going to be my critical number. So I just labeled that so I don't forget where I got the 2 from. So critical number, that's my 2. But I have 2 endpoints. I have 0 and 3. So I need to make sure that I check those as well, because remember, an absolute max or an absolute min could occur at the endpoints. All right, so I need to figure out a y value for 0, 2, and 3. You could use a table feature on your calculator if you have that as an option to type this in, find your table, look up the values. I don't have that here to show you, so we're going to do it the calculating way. So the first one we need to find is f of 2. Now remember, we're looking for a y value, not a derivative value. We're looking for a y value. So it goes back into the original equation. So that's going to look like 3 times 2 raised to the second minus 12 times 2 plus 5. We can solve that down. If we solve it down, well, let's see here. 3 times 2 squared is 4. 3 times 4 gives us 12. Minus 12 times 2 is 24 plus 5. It looks like when we simplify that down, we're going to get -7. So f of 2 is -7. Now we still don't know if that's an absolute max or an absolute min. We can't tell yet, so we got to keep going. So let's see if we can do f of 0. So f of 0, that's going to look like 3 times 0 squared minus 12 times 0 plus 5. Well, that'll be 0 minus 0, so that's just going to be 5. So 0, 5. Again, we don't have a whole lot because we still have one we need to finish. So now we need f of 3. So we'll have 3 times 3 squared minus 12 times 3 plus 5, putting that 3 back in for our x's. So if we calculate this out, well, 3 squared is 9. 9 times 3 is 27. 12 times 3 is 36. So it looks like that's going to give us -4. All right, now we can figure it out. So here's my points. We need to look at these and figure out what's happening. Remember, the absolute max is the largest y value from our table. So our absolute max right here, it looks like it's going to be 0, 5. So this is our absolute max. And remember, the absolute min is the lowest y value from our inputs from our domain. So -7 looks like the lowest one we've got. So this is going to be our absolute min. And what is 3, -4? Well, it would be a local, but we weren't asked for that. So neither an absolute max or an absolute min. If it asked you for a local max or min, well, we could check and see. We don't know what's really happening right here, but it is an endpoint, so we know it can't be a local. So neither is the best we could do. If our domain were extended, it's possible that at 3, -4, we could have a local max or min. Our domain is not extended, so we didn't calculate that. If you were to draw the graph, you'd be able to see what was happening, and then you'd be able to tell. But from the information we're given on the interval we're to consider, 3, -4 is an endpoint, so it cannot be a local, so we're all done. We found our absolute max and we found our absolute min. Let's look at the next one. find the absolute maximum and absolute minimum values of f of x equals 4x to the fourth minus 2x squared plus 3. On the interval, here's our x's, -2 to 3. Okay, let's try this one. So the first thing that we need is our derivative. So we have f of x equals 4x to the fourth minus 2x squared plus 3. So that means that f prime of x is going to be 16x to the third minus 4x. And that looks like it because the derivative of 3 is 0. So let's say 0 equals 16x to the third minus 4x. I see a common 4x there, so let's pull that out. So if I pull 4 from 16, I have 4 left. 16 divided by 4 is 4. If I pull an x from x to the third, I have x squared left. If I pull 4x from 4x, all I have is -1. Remember, you have to be able to distribute it back to get back to your original. So it looks like we can split this to 0 equals 4x and 0 equals 4x squared minus 1. Well, 0 equals 4x. Okay, well, that just means that 0 equals x. Divide both sides by 4. This one, do you see? It's still a difference of squares. So 4 will become 2 and 2. X squared will become x and x. Minus 1 and plus 1. So when we FOIL it back, we get back to here. So we got to split this one again. 0 equals 2x minus 1, and 0 equals 2x plus 1. I don't have enough space to finish it there. So let me just move these over here so we can put them all together. Well, actually, let me just shrink this down right here, and then we'll be able to put it together. There we go. So now we can see add our 1, divide by 2, and it looks like we get 1/2 equaling x. Subtract our 1, divide by 2, and -1/2 equaling x. We have more to check this time. We have 3 critical numbers and we have 2 endpoints. So let's go ahead and make our list again. So we need our x's, we need our y's. It doesn't really matter what order you put them in. I like to have all my critical numbers first. So -1/2, 0, 1/2. And then I put my endpoints next. So 2 and 3. So these right here are my endpoints. And then these right here are my critical numbers. It doesn't matter. Some people like to put them in order. So for example, -2, -1/2, 0, 1/2, 3. That's fine. I like to keep it separated this way because now I know my endpoints right here cannot be a local max or a local min. So if I was trying to find any information about the local max and min, I would know not to use these, but just to look at these. So that's why I like to have it separate. So we need to put in our different values and solve. So if we put 1/2 back in up here, I'll let you type it into your calculator and calculate it through. It works out to be 11/4, which is the same thing as 2.75. And that works out the same for the -1/2 and the +1/2 because our x's are both to an even power here. If we put 0 in, 0 minus 0 plus 3, we're just going to get 3. And if we put -2 in, follow it the whole way through, it gets kind of big, 59. That to the fourth and that to the second, make it get pretty big. And then if you thought 59 was big, when you put 3 in, it will be 309. So again, just putting those right back in where you see the x's and calculating it down. So now we can figure this out. We can look at what we have and we can decipher. I think 309 wins. So that's going to be our absolute max. It's an endpoint, but that's okay. An endpoint can be an absolute max or an absolute min. 359, nope. These two are our smallest. So both of these are going to be absolute mins. They're both the same value. They're both that 2.75 or 11/4. So when we're looking at our minimum, they're the same amount of minimum, if that makes sense. So they're at the same point. in terms of the y-axis. So we have two absolute minimums because they're the same. So 11/4 is the result from both -1/2 and +1/2. So both of those, the combined absolute min. Think of it like a tie where you have to share first place. Kind of the same idea. Let's look at number 11. After the consumption of an alcoholic beverage, the concentration of alcohol in the bloodstream, blood alcohol concentration, or BAC, surges as the alcohol is absorbed, followed by a gradual decline as the alcohol is metabolized. The function C of t equals 1.2 t e to the -2.6 t models the BAC, measured in milligrams per milliliter. In a test patient's bloodstream, T hours after rapidly consuming 15 milliliters of alcohol, what is the maximum BAC during the first 3 hours, and when does it occur? Okay, there's a lot of information there. Let's see what we've got, and let's see where we can start, and we'll go from there. So we have this BAC level. So after the alcoholic beverage is consumed, the BAC level, it says it surges because the alcohol is being absorbed. It then starts to gradually decline as it then becomes metabolized. So here's our function. So let's see if we can start with that function, and let's see what we can do from there. So we have C of t equals 1.2 t e to the -2.6 t. All right, so right here it's asking us what is the maximum. So that means that we need to take our derivative and set it equal to 0. And then we need to test our point to see if that is actually a maximum. So let's start with this. Can we take our derivative and set it equal to 0? So first things first, we need a derivative. So C prime equals, you got to think of this as a little mini product rule right here. Here's the first, here's the second. So our product rule says first, so 1.2 t times the derivative of the second. And this is an e to the f of x. So we have to do our little chain rule within our product rule. So e to the f of x is e to the f of x, so e to the -2.6 t times the derivative of our f of x, our exponent. So that's just -2.6. So first times the derivative of the second plus the second, e to the -2.6 t times the derivative of first. Well, the derivative of 1.2 t is 1.2. Okay, there we go. We took the derivative. So now we need to take the derivative and set it equal to 0. So let's set all this equal to 0. There's a lot going on here. I noticed that I have an e to the -2.6 t in both of my terms. I also noticed that I have a 1.2 in both of my terms. So I'm going to try to make this a little bit easier because remember, we set it equal to 0. We're going to have to split it apart like we did up here. And I'm going to factor out that 1.2 e to the -2.6 t. Now, if we do that, right here, we're left with this t. And here, we're left with this -2.6. Here we factored everything out, so we have to put a 1 in its place. So -2.6 t plus 1. The good news is now I have two separate terms multiplied together, so I can set them both equal to 0. So let's see what we can do from here. Let's see if we can solve this down. Well, divide both sides by 1.2. So 0 equals e to the -2.6 t. So if I take the natural log of both sides, we have a problem. Type natural log of 0 into your calculator. What happens? You're going to get an error. You can't do it. So there's no zeros here. So there's no t's that's going to make 0. That one's all done. Let's try this one. So subtract our 1 from both sides. Divide by -2.6. So we'll have 1 over 2.6 equals t. And if you divide that through, it's approximately equal to 0.385. There we go. Now, what does that tell us? Well, that is our critical number. So we have some endpoints here. See, it says first 3 hours. So our endpoints are going to be 0 and 3. So we found that 0.385 is our critical number. So we need to see if that's a maximum or not. And we need to try to figure out when that would occur. Well, our t value is when it would occur. So 0.385 is when, that's our time, and that's about 23 minutes. But now we need to see if that's the max, because we don't know for sure if it is yet or not. We need to check the endpoints of our interval. So again, we have some values that we need to check. We need to check when t is 0, 3, and 0.385. So let's make our list. We need to check t, and then this will be c of t instead of x and y, because a little bit different notation, because our equation is labeled c of t. So we need to check our critical point, which was 0.385. We need to check 0, and we need to check 3. So we have some things to check in here. I didn't leave myself space to write these checks either, so let me just move this over. There we go. All right, let's start with the first one. So when we have t as 0.385, that means that we need to put 0.385 back into our original equation. So that's going to look like 1.2 times 0.385 e to the negative 2.6 times 0.385. And if you type all that into your calculator, you should be getting 0.1698. Okay, there's our first one. Now we have t of 0. So that will look like 1.2 times 0. And we could really stop right there because we know what that's going to be when you multiply anything by 0. But we'll finish writing it out. So when we put in 0, we're going to get 0. I'm alternating colors here. Hopefully that's making it a little bit easier to see. And then the 3, so that would give us 1.2 times 3 e to the negative 2.6 times 3. So 1.2 times 3 e to the negative 2.6 times 3, that'll give us 0.00147. So let's see what we've got here. We're trying to find our max, and we're trying to figure out when it would be. So that means we need our highest value. It looks like our highest value is right here at 0.1698. 0.00 is pretty low, 0 is low, so it looks like our highest value is this 0.1698. So this means that we'll have a maximum when t is 0.385, and the BAC level would be the 0.1698. So that would be the milligrams per milliliter. So our max, I'll just write it over here as a summary, is going to be at t equals 0.385, and then c of t is going to equal 0.1698, and our units would be milligram per milliliter.